Good morning, everyone. This is Penny from Wisconsin Land+Water, and welcome to our webinar today. It's recording now. Okay, today our presenters are Perry Lindquist and Roger Bannerman. And before we begin, I am just going to go through a few things with you, and then I'm going to turn it over to Perry, and Roger may chime in here or there. And just wanted to mention that this webinar is kind of being provided by the State Interagency Training Committee, SITCOM. They're the ones that work on this. And then Perry's going to be telling you a little bit about the Standards Oversight Council, commonly known as SOC. So again, we're going to be offering one Soil and Water Management CEU, or Continuing Education Unit, and one PDH. And you can either self-report the PDH, or if you want a PDH certificate, send me an email. But usually we only offer the PDHs and CEUs for the live webinar. And unless you're listening in today, and let me know that on the email. So I'm going to tell you a little bit about Perry. Perry serves as the Land Resources Manager for the Waukesha County Department of Parks and Land Use. He has authorized and administered stormwater management ordinances for over 35 years for both Washington and Waukesha counties. He has also been active in the Wisconsin Standards Oversight Council, SOC, for 25 years, and served as a SOC team leader for the development of the Rain Garden Technical Standard. So at this point, I'm going to hand it over to Perry. So welcome, everybody, and it's your turn, Perry.
All right, thank you, Penny. I'll just start out just mentioning that Roger Bannerman will be joining me, and I think I have a, there we go. I have a picture of us both on the side here. Our outline for the presentation today is, first we're going to just talk about what is and why a rain garden technical standard, what the process was that we used to develop it, and then go through the standard in detail, at the same time touching on the user guide or the manual. And I'll show you a picture of both these, and they're both on the website shown right on this screen. But we're going to focus on the technical standard. The user guide is a how to apply the standard to the field, and it's very helpful, and Roger developed one back in 2003 that we basically updated after we finished the standard today. And then at the end, we'll hopefully have time for questions. So first, why work on a rain garden technical standard? Well, similar to all technical standards, the primary purpose is to maximize success in their installation, the protection of our natural resources, and on the flip side, limiting the failures and associated conflicts and liabilities that might be associated with that kind of work. And really it's about ensuring fairness in bidding processes, cost-sharing programs, and regulations. And in fact, the regulations were some of the driving forces to develop the standard at this time. The first of those is the shoreline zoning and impervious surface limits through NR 115. We also use rain gardens quite often on small sites for stormwater permits to meet NR 151 requirements. Some municipalities cost share rain gardens and even get MS4 credits for them under NR 216. And I think the reason the contractors were so interested in this is to get that level playing field that I was talking about in the cost sharing and bidding processes. So developing the standard itself, the process we used is through the Standards Oversight Council. Like, I just wanted to give a shout out for SOC. It's been ongoing for about 25 years now, and it's in a very accountable, transparent, and science-based process. It gets all the state, federal, and even local governments on the same page on a single set of technical standards that we use in a wide variety of conservation programs. So it's been very successful. Thanks, Penny. So one of the key components of the SOC process is a broad public distribution process that allows anybody to comment on the draft standard before it's finalized. For this particular standard, it's considered a new one because there was no technical standard, but we did have the how-to manual from 2003 that that Roger and company spent a lot of time on. So we did use that as kind of a starting point, but it was a little bit bigger project than we thought it would be to put it into a standard format. The owner of the standard, or the custodian we call it, is the Department of Natural Resources. And the target audience of the standard, we really talked about trying to make it as simple as possible for homeowners to use. But you'll see as we get into it, it does get a bit complicated just because that's the way the site conditions sometimes work out. But landscape contractors and developers and engineers, and they're all target audiences in this case. As far as the timeline, the team was formed in December of 2016, actually, but the standard development process pretty much took up most of 2017. We did take a break for some modeling work and to develop some graphics, and then we were finally able to release it for public comment in spring of 2018. And then after we incorporated all the comments from that process, it was submitted to DNR, and final approval was in September of 2018. And then there's somewhat of a parallel process that was occurring for the user guide, or I never know what to call it, Roger, the manual. We updated that as well. As soon as we were pretty much finalized on the standard, then we could update the manual to be consistent with that standard. And this is a picture of the two documents I'm talking about. The text standard is number 1009. It's very plain Jane looking, just words on paper. There are a few graphics in it, but it's following a process or a format that was consistent with NRCS's formats, so that we're all on a very similar format for all standards. The rain garden user guide, or the manual, is very much picture oriented and how to. So we'll touch on some of that as well. There's also a black and white version available for download on the manual. So as far as the standard itself, the definition of a rain garden is the first thing it hits on, and it's got 4 key components. It's a shallow depression planted with a dense cover vegetation. It captures stormwater runoff from a small drainage area and infiltrates it into the underlying soils. You'll see the italicized words throughout the presentation. That means that those terms are further defined in the standard itself. And I recommend that you read those early on because it offers a lot of clarity to the standard as you go through it. The next section is called purposes, and the purposes of a rain garden, it can be used individually or as part of a system of stormwater management practices for one or several of these purposes that you see listed here, including infiltration, reducing peak flows, groundwater recharge, you name it. Adverse drainage is something we'll talk about as we go through this, but it's actually a tool to prevent that, but it's also something we have to be cognizant of as we develop a rain garden. So the next section in the standard is called conditions where practice applies. And in this case, a rain garden is best suited for small rooftops or drainage areas, slopes and soils that are suitable for infiltration. Usually they're located on a landscaped area on site, nearby a rooftop, such as shown in this picture. We're targeting low pollutant sources, or those roofs in the drainage areas. But you will usually capture some runoff from nearby landscaped areas as well. The next part of that conditions where practice applies is kind of the reversal of that statement, as in where is it not suited. And in this case, rain gardens do not belong where you're going to get any kind of a sediment load or a large area of impervious surface or salt-based deicers. So parking lots are a real problem for rain gardens. It's got a limited application where you have shallow bedrock, high groundwater, or clay soils. And we'll be diving into all of that as we get into the standard as well. The compliance with law is pretty much standard language in all technical standards, but it reminds people that a regulator can use a technical standard to demonstrate compliance with several codes, such as I listed in the previous slides, but the standard is not a regulation in itself and does not contain any code language. So that's often a distinction that gets lost, but it's important because these standards are not just used in regulatory programs. There are a few cross-references in codes to standards, and in this case, we actually included a cross-reference in the standard back to the code, which is NR 151, just to let people know that they can use the rain garden standard or practice to meet the infiltration requirements contained in that code. And because NR 151 is such a key performance standard in the state, we thought it would be a good thing to cross-reference. So the next section of the standard is called criteria, which is really the meat of any and all technical standards. It's pretty much the requirements that you need to follow in order to meet the standard. And in this case, it's divided into several sections for site assessment, the design, the construction, planting, and the O&M. We will discuss each one of those. The first section is on the site criteria, and it requires a site assessment up front, which includes all of the following elements, which we'll also be going over in detail. But and then I'll show you an example right at the end of that section on how to use that criteria. The first one in the site criteria is setbacks, and it talks about not allowing the rain garden to be hydraulically connected to buildings, wells, and septic systems. And hydraulically connected is a defined term. I've just shortly defined it right below, where it means that either surface runoff or subsurface flow is connected to the other structure as through a conduit. And the conduit can be a very pervious layer of soil. So it's something that is not going to be real obvious, and you might have to get some professional assistance to work through it. There's absolute minimums included in the tech standard, including 10 feet from a full basement, 5 feet from a frost footing, 8 feet from a well. There's a note in there that says if you're within 25 feet of a well, you should get a regulatory review to help with that hydraulically connected issue, because just because you meet the setback doesn't mean you automatically meet the hydraulically connected provision. So be careful with that. And septic systems are another one where you just don't want to be connected to it, but it still has an absolute setback of 5 feet. Soil limitations, I would say that as with all infiltration best management practices, soils are the #1 issue and the biggest reason for practice failures. As far as this standard, we included a 1-foot vertical separation from groundwater as a minimum, a 1-foot vertical separation from bedrock as a minimum as well. And you might wonder, wow, that's not much of a setback or a separation distance, but remember, in this case, we're talking about targeting very clean water from roofs. So 1 foot of soil material can provide plenty of filtration for that kind of runoff. There's a note in the bedrock section that says if a soil survey shows bedrock is within 1 to 3 feet, you should really consult a professional. In fact, the little asterisks next to all these are items that might require a professional consultation. Clay soils, of course, is a real problem for getting infiltration. The most fine soil that we allow in this standard is a clay loam. And even if that one, we're strongly recommending native or deep-rooted plants in there to help get through that soil layer. So this just is the asterisk I was talking about. So slopes, it says in the standard, locate the rain garden on 8-to-1 or flatter. Cut and fill slopes within the rain garden itself cannot exceed 2-to-1 unless the slope is supported by landscape stone or a block wall or something like that. And if you look at this little graphic there, that slope would be way too steep for a rain garden. That looks more, I mean, there's no scale there, but it looks more like a 4-to-1 to me. So you need to have relatively flat slopes to work with for this practice. The drainage area is something you have to be very cognizant of. The standard allows a maximum of 3,000 square feet of impervious surface, which should not be a problem on most residential properties. Remember, you're not capturing the whole roof off of one downspout. You're usually capturing about a quarter at the most. So small commercial buildings are also acceptable. And then there's a maximum of 5,000 square feet for the total drainage area. And that includes any landscaped area such as a lawn. So it's important to know where all the drainage goes on the property that you're locating the rain garden. If there's a swale in the back, if there's runoff coming in from the adjacent lots and that kind of thing. You can divert the flows from those kind of areas, or you could even split the rain garden into different cells if needed, just to stay under these maximums. And again, the drainage area should not have salt-based deicers or any construction site sediment going on in it. For erosion and adverse drainage, the standard says that you need to direct the outflow out from the rain garden to a stable outlet and not create any erosion or adverse drainage. And adverse drainage is defined in the standard, but it essentially means negative impacts on nearby properties or structures. So a lot of times you can use a rain garden to solve an adverse drainage issue, but at the same time, you also need to be careful you don't create an adverse drainage. And I'll point out a couple of examples of that in a minute. And then the standard just has some general language about minimizing damage to roots of desirable trees. Generally, this means staying outside of the drip lines of those trees. Usually what you're trying to plant and grow in a rain garden won't grow in shade either, so that's another reason to stay away from that area. And I believe the last thing in the site assessment section talks about utilities, and it just says be careful, get proper approvals from authorities if needed for buried utilities. You probably want to avoid areas where sewer laterals, water lines, electric lines, things like that are buried, because you're, infiltrating a lot of water in those areas. So that was the end of the site assessment section. I just wanted to apply that once and show you an example of using the site assessment criteria. You remember the one where it talked about not applicable where large areas of impervious surfaces or salt-based deicers, and limiting clay soils. In this example, the rain garden was really well done. They put prairie sod in the bottom and bordered it with a mulch and then sodded around it. But the only problem was the site really was stacked against it because it had clay soils, you have large impervious surfaces. And so the first two, the impervious surface and the salts, are something that'll eat away at the rain garden in the long term, but the clay soil kind of gets it right away. And in this case, it was pretty obvious within weeks that it would fill up with water and then not infiltrate. So the plants start to die immediately and everybody gets frustrated. So it's important to do that site assessment. That's the take-home message there. The next section in the standard gets into the actual design criteria. And that's divided into 11 different components, which we will go through. I won't read them right here, but these are the titles of the next sections that we'll cover one at a time. before we do that, pretty much just an overview of the components of a rain garden. You'll see the inflow areas coming in off of a downspout, or it also could be coming in off the lawns in this case. The design ponding area is essentially the bottom of the rain garden. I think in the administrative codes, they call it the effective infiltration area. The berm, or the downslope edge, which is kind of a weird term that we came up with, but I'll explain why we did that. That's on the low edge of the rain garden. We talk about a design overflow, and it's optional, but we point out in the standard when you should use it. The planting bed itself includes the ponding area and the back slopes, and we have a very detailed section about what to do with that and the vegetation planning involved. So first we'll talk about the ponding area, which, as I mentioned, is the bottom of the rain garden, not including the side slopes. And we spent a lot of time on sizing the ponding area. The ponding area depends on three factors: the depth of the ponding, the soil infiltration rate, and then the target percent of average annual runoff volume that you're shooting for. And we created a table in the standard that's very easy to use, but I can tell you that is based on extensive modeling, and I'm going to have Roger explain some of that in a second. And it's also based on a preferred drawdown period of less than 24 hours, which is kind of in the background. So it's not something you have to calculate, but it's built into the model itself. So the table looks like this, and those three factors I'll just mentioning is the ponding depth is on the left. So that's a design element that the rain garden designer would use. Another design element is the percent runoff control volume, which are these three rows here. And then the last factor is these 5 soil types / infiltration rates. So this is what the table looks like. I'll be spending some time on how to use it, but I thought it would help to have Roger explain a little bit of what went into the table. Roger, you want to take it away for a couple slides?
Yeah, sure, fine. You want to show the next slide, or?
You bet.
Okay. Perry's explained the variables that we have to worry about. And the challenge is how to keep all those balanced as the rain is actually happening. So we developed a tool that essentially is an accounting tool. So it keeps track of how much rain is falling on the rooftop, how big is the rain garden that you're building, what is the infiltration rate, and so in the end, you can make many runs with the model, as many of you know, to find out how big that effective infiltration area has to be, and how relative to how deep the pond is and so forth, to actually accomplish the goal that Perry was showing you in the table. Do you want 75% control of the annual rainfall? Do you want 100% control? And those are important things to decide, because it certainly affects the size of the rain garden that you're building. In the manual that Perry was talking about, we just assumed 100% control, and that gave us a lot of, well, it's a conservative way of looking at it, because maybe someone would make it smaller than they should, you know, that kind of thing. But the model itself is based on usually 30, 40 years of research. You can see there we have a schematic. So a person put the various variables in there, that's the size of the rain garden and so forth, and with the model calculate how much control they're getting. But of course, we don't want anyone to go through all that. So behind the numbers in the tables is many runs with this source load management model called SLAMM. The DNR has supported this model for a long time. And so it's come up with numbers that we seem to be working. We've used some of the numbers for more than 20 years, and some of the rain gardens have been built. So I have a lot of confidence in it. So hopefully, as Perry started out with presentation with, the standard hopefully ensures success. If you follow the standard, you'll be successful. And hopefully the model is a big part of that, so you make sure the thing is the right size. Let's go to the next slide. So here's some lines that I just drew for you, showing the percent control on the y-axis and the area of the rain garden on the x-axis. So if you look at the red line, that's for a rain garden that is 6 inches deep. And again, these are the variables that I put into the model, you know, over and over and over again to get the curve you have in front of you. So we say, okay, I want a number like 60% control, and you can see that's the first dot on the red line, and the rain garden is only about 400 or 500 square feet. But as you want more and more control, all the way up to 100%, when it's 100%, the rain garden is 2,000 square feet. So it's very important you decide what you want. Of course, the obvious thing that's happening here, you have bigger and bigger rain gardens as you want to control bigger and bigger storms. So if you're controlling a bigger percentage, you know, 100% versus 75%, you're obviously controlling some bigger storms. So that's a volume thing. And so therefore, oh yeah, Perry just put the dashed lines on there. You can see that it gets bigger as you're controlling more storms. So this is what the model's doing for you. It goes through all these calculations, all those points on those curves. And so those curves become the table. I'll be happy to answer more questions at the end, but I don't want to slow Perry down too much. But this is the basic idea, is that we have a lot of confidence in the table. It's based on a lot of research and a lot of model runs.
Thanks, Roger. Yeah, if there's somebody who still doesn't have their mute button on, I would appreciate you hitting that, because we're getting a lot of background. So like I was saying, you have the design factors in yellow, but then you have these 5 columns of soils, and you have to figure out which one is the right one to use. So that'll be the next part of the standard. The soil type or the infiltration rate that you pick. There's 2 methods allowed to determine which column you end up in. You can either conduct a soil texture analysis, and we've included an attachment in the standard to walk through that process, and I'll do that on the next slide. Or you can conduct an on-site soil infiltration test. For a soil texture analysis, you would collect a sample 4 to 6 inches below the planned surface or the bottom of the rain garden. We're assuming that we're a shallow depth for those rain gardens. If you're concerned that there's some underlying soil that is going to be serving as a limiting factor, such as what you see on the right here, then you might want to take a sample of that as well and do the same test. But it's pretty straightforward as far as doing a texture analysis. There's like 3 steps to it. First, you try to roll the soil. You take that sample, a few teaspoons of it, and you try to roll a ball with it. And if you cannot make a ball, then your soil is sand. Right there. If you can, the next test is to do a ribbon test. If you cannot make a ribbon, then it's a loaming sand. If you can make a ribbon, such as the one on the right here, but it's over 2 inches long, then it's a clay soil, and it's really not a good site for a rain garden. So that'll pretty much rule that site out. If you can make a ribbon 1 to 2 inches in length, then it falls into that clay loam category in the table 2. And then if you're in that less than 1 inch of a ribbon that you can form by squeezing it through your thumb and finger, like is shown right there, then you got to do one more test, and then you put a bunch of water on your palm and you smear it around with your forefinger, and you decide, is it gritty like sugar? If so, then it's a loamy sand. If not, then it's a silt loam. So you see what's left here is the 5 categories of soil texture that we used in the table 2. In fact, after I put this slide together, I realized there's extra boxes in here we might be able to just edit out, because we aren't using any additional soil textures. So it's a pretty simple process that anybody could do, so that's why we included it in the standard itself. If you don't do the soil texture analysis, then you need to do an infiltration rate. And there's two methods of infiltration testing that we allow in the standard. One is through a double ring infiltrometer, which pretty much has to be done by a professional, or again, there's a simplified method that we outline in detail in an attachment to the standard, in attachment 1, and it involves just using some materials that you'll find around the house usually, or you can get at the hardware store. No matter which method you use, the maximum infiltration rate that is available in that table, when we get back to it, is 2 inches per hour. This is what the home version of this, or attachment, what did I say? Attachment 1 looks like. There's a little drawing inside, but essentially you're taking lawn edging and you're cutting it into the soil about 4 inches deep in a 2-foot wide circle. And then inside of that, you take a 4-inch PVC pipe and you cut that down into the soil another 3 inches, leaving 3 inches above. So it's a 6-inch high piece of pipe, or you could use a coffee can or something like that. And then you mark it in inches on the side. And then you add water all around that exterior, or the, let's see, go back to this picture. You add water around the pipe in the middle, and you wait 24 hours. You fill it all the way up to the top of that pipe, you wait 24 hours. You come back to the site. If there's still water sitting in that area, then it's no good for a rain garden, because now you're less than 0.15 inches per hour, which is off the chart. And we would pretty much rule it out. I'll talk later about maybe possibly using other practices, but for just a rain garden using native soils, it's not going to work. If the water is gone, then you fill it back up and you start to measure how long does it take to leave that center pipe. So you're keeping it wet on the outside, but you're measuring the infiltration rate on the inside. The idea is that you're not allowing the water to spread sideways. It's being forced to go straight down into through the pipe. So it's very similar to the professional double ring infiltrometer, except it's just a simplified version of it. So getting back to the table, the two methods then, you either test the soil to get into one of these categories, or you test the infiltration rate, and then you assign one of those categories through that. Now I'll just show you an example of using the table. In this case, it's a single family home with 800, or the rain garden would be located in the front line here. We have about 800 square feet of pervious surface or lawn that would drain to it. We're trying to capture this side of the house in black, which adds up to about 900 square feet of impervious surface. The site has, in this case, silt loam soil. We're targeting a 90% runoff control, which is consistent with NR 151. We're shooting for a rain garden depth of 6 to 7 inches. So you go back to the table and you pick out your silt loam soil, for the pervious surfaces, you always use 75% runoff control volume. So for the impervious surface, you have to pick your target, but for the pervious surfaces, you always use 75%. So in this case, we're using the 6 to 7 inch rain garden depth. So for the pervious area, you pick a factor of 9. And what that means is it's 9% times the square feet of the pervious surface. So that 9.09 times 800 is 72 square feet. That's just for the pervious part, or the red on the map here. So now do the black. You go back to the table. We're shooting for, we're still in that silt loam category. We're shooting for that 90% runoff control. We're in the 6 to 7 inch depth. So for the impervious part of the watershed, you use a factor of 0.14. So you go back to the numbers here, and you take 900 square feet of impervious surface times the 0.14 equals 126 square feet. You add the two together, 198 square feet of ponding area. That is what you're using to design the ponding area or the bottom of the rain garden. In this case, it would add up to about 11 feet by 18 feet. Now, if that is a size that's, let's say it's too big, it's not going to fit into our landscape plan or something like that, then you go back to the table, and one option would be to go to a deeper rain garden. That would change your 90% control from 0.14 to 12%. So in this case, I highlighted you're changing it to an 8-inch depth, which changed this from 14% to 12%, and it knocked this down from 198 to 180. Not a big deal, right? So you only lost a foot on the size of your rain garden. So increasing depth, at least in a silt loam soil in this case, doesn't really work real well. But how about reducing the watershed? Let's look at the pervious surface first. How about if I turn that downspout over here so that instead of flowing that way, it comes directly to the rain garden, and then we can let this outside part flow around the rain garden. And how about if, well, this goofy pipe here, I call it the headbanger, they had it showing going over the sidewalk. Maybe you decide that's not such a great idea, so let's eliminate this part of the impervious surface and reduce that watershed as well. So now we're reducing the pervious area to 500 square feet. We're reducing the impervious area to 650 square feet. You re-add those numbers and take the 9% times the 500 plus the 14% times the 650, and you end up with 136 square feet of ponding area. Well, you've significantly downsized the rain garden now, went from 11 by 18 to 10 by 14. So that's just an example of how to use the factors in the table to determine the end game or the sizing of it. So moving on to this, into the standard itself, walking through the rest of the criteria, the next one includes berms. For the berm, usually you're using excavation, so you're digging down a small amount and then using what you're digging down to create the berm. But if you're very close to bedrock or groundwater, that might not be an option, and you might have to import the soil to maintain that 1 foot separation. Either way, the top width of the berm needs to be 12 inches, and the side slopes of the berm cannot exceed the 2-to-1. And compaction of these berms is very important. You might think, well, what's the big deal? But if they settle and all of a sudden water is flowing over the top of them, then you're no longer getting the flow depth or the ponding depth that you designed in the practice. So the next part of the standard talks about the downslope edge. And the reason we use this term is that if a rain garden is just cut into existing soil and you exported all the material that you cut out, well, then you're not creating a berm, and it's really just a cut edge, or we're calling it the downslope edge of the berm. So whichever one it is, whether it's the top of the berm or the edge of the lawn from the existing ground, that's controlling the elevation of the water inside the rain garden. The downslope edge, by the standard, must direct outflow to a stable outlet, and it must avoid creating adverse drainage conditions, which affect other properties or even your own property. Just looking at this picture here, it's almost looking like you'd have more of a risk of affecting your own property. If you don't get this edge right, and this becomes the low edge, and then the water starts flowing toward the house, that would be pretty much creating an adverse drainage condition on yourself. So it's important to get it right. If a certain discharge flow path is needed to avoid any kind of adverse drainage, then the standard requires you to use a design overflow, and I'll go through that in a second. The last part of the the downslope edge or the berm just talks about protecting it from erosion using mulch or netting or matting or something to that effect. So for a downslope or for a design overflow, you're basically cutting into the berm approximately 3 inches. Or another way to look at it is you're building the top of the berm above that overflow. So it's creating a small channel through the berm, directing the overflow to a certain area that's stable and will not create any drainage problems downstream. It's not necessary, but it is desired and required actually if there is any risk to downslope drainage. So you build the top of the berm 3 inches above that overflow depth because the overflow elevation is now your ponding depth. So you need to be careful about that. Don't design it to be the top of the berm and then cut 3 inches into it for this overflow. Then you've kind of cut your design ponding depth significantly. The design width of the overflow is actually something that came up, and we ended up creating a table in the standard that dictates what width to use for that overflow, which is a 1 to 3 foot range depending on the size of the impervious surface drainage area above it. So it's pretty easy to use. The planting bed is the next part in the standard. Here we're talking about the bottom of the rain garden. It needs to be as flat as possible. In fact, 0% slope is the ideal, but we do allow a maximum of 1% slope from one side or one end to the other. That's why you need a flatter site to work with on these types of practices. If the subsoils are difficult for planting, in other words, as you start digging in for your rain garden and you start hitting a lot of rocks or sands or something like that, and it's going to be difficult to plant on, then you need to plan to over excavate the rain garden by several inches and then reuse that topsoil that you pulled out for the planting bed. If you're using native plants, it's not as important and you don't need that much topsoil to work with. If you're planting turf in the bottom of this thing, you need as much as you can so that it doesn't dry up and die on you. Soil amendments can also be used to enhance the planting, such as compost, and I'll get into some of that later. As far as a vegetation plan, the standard allows the use of native plants, perennials, or turf grass. I'm getting a beeping sound, Penny. I don't know what that is.
I don't know what that is either, but I don't know if it's somebody else's computer that's on. Don't know. I guess hopefully it goes away soon. Sorry. Don't know what that
I
is.
suspect somebody put us on hold or something on your phone.
Right.
So anyways, while everybody on the team agreed that deep-rooted native plants are the best, if you're using the practice in a regulatory setting, the science says that turf does still work. So that's why it's allowed in the standard. You need to include your methods and timing and your fertilization and watering, all that in your vegetation plan. You want to use plants that can tolerate overwatering or drought, and that's why we think the natives work the best, because they can withstand those growing conditions, and also their long roots just help with the infiltration. If you use turf grass, we've included some limitations in table 2 in the clay soil or the clay loam soil column, because the ponding depths or the drawdown times get way too long, and we were trying to keep them. I think those started getting over 48 hours, if I remember right, Roger. So that's why we put limitations. So on those, we only allow native plantings using that type of soil and those ponding depths.
Yeah, that's right, Perry. The model told us it was just going to be too long, so we shut it down.
Okay. So that was another part of the modeling that Roger was doing. As far as planting standards, for native plantings, you can use plugs, prairie sod, or seed. If you use plant plugs, it dictates 1 plant per square foot. Anchoring the sod, of course. Seed, really, it's allowed, but it's not recommended at all. It's the most difficult. Trying to get seed of any sort growing in an area where you're directing your downspouts is going to be difficult. You'd most likely have to divert all the downspouts for the first year until you get a good cover going. Water and weeding is critical in any method that you use to control the invasives. And if you use turf grass, of course, you can use sod, which would work great. Just need some watering the first couple of weeks. And if you use seed, again, we wouldn't recommend it, but we refer you to UW Extension publication for lawn establishment. And if I remember right, I think we required some kind of erosion matting on that as well. Woody vegetation is allowed on a limited basis, so some shrubs, small trees, but we just don't want it to shade out the other plants in order to keep that good ground cover. Soil treatment is something that's required in the standard in order to accomplish several things: the erosion control, weed suppression, avoiding compaction, as well as preserving soil moisture are all big things about soil treatment. If you're using plant plugs, we require shredded mulch 1 to 2 inches, and you'll see a picture of that down here. We purposely said shredded, not the chip stuff, because the experience is that this stuff just floats around too easy and moves right out of place at the slightest flows. Staked erosion matting is another way you can provide that soil treatment, and that would be like on top of a seeding. I've seen people cut through it for plant plugs as well, or you can do a sod such as turf sod or prairie sod. All those are good soil treatment measures. Stake erosion matting on design overflows for soil treatment, and controlling those downspout pads, lining them with rock or buying a pad or something is also just to avoid getting that sediment loosened up and carried into the site. For construction of the rain garden, if you have a good back and a shovel, you can usually do it with that. If you have a bad back like me, you might want to rent one of these little buggers and do it the easy way. But no matter what you do, you want to avoid construction on wet soils. You want to avoid traffic on the planting bed. So you try to keep any machinery like this outside of the planting bed, especially rubber tire stuff. But the little tracks on here shouldn't be too bad if you had to get in there. If the soil does get compacted, there's some remediation measures, but they may not be all that effective, such as rototilling, compost, again, planting deep-rooted plants, but that could take a couple, 3 years before the soil or before the roots get growing deep enough. And you could also try deep tilling, but that requires some equipment itself. So really avoidance is the key when it comes to compaction. We talked a lot about the need for professional assistance in the standard, and I mentioned it several times where it might come in handy. When you get into larger, deeper rain garden designs, anything with an outlet pipe design, we purposely avoided that in the standard because that opens the whole door to flood routing, and now you have to have somebody who knows what they're doing. So get a professional if you're getting pipes involved. If you do have groundwater or bedrock issues, that would be a good time to get a professional. Or if you're just trying to interpret your soil or in your infiltration testing. Watershed delineations can even get tricky sometimes, figuring out where the roofs go and where the ground goes. And like we talked earlier, the hydraulically connected issue is something that you might have somebody weigh in on. Clay loam soils in particular are a challenge for all infiltration practices because of the long drain down times. It's hard to keep the soil and the plants healthy with that going on. We really require the rain garden to stay shallow in those types of soils. We require deep-rooted native plants in those kinds of soils. If possible, diverting the flows away from the rain garden for the first year is recommended, as well as amending the soil. And if all else fails, adding a drain tile around the bottom, which again, you might need to get a professional involved because now you need an outlet for your drain tile. As far as plans and specifications, it's pretty much standard stuff. You need a vicinity map showing where the rain garden is located in relation to its flow paths and drainage areas, kind of like I was showing you earlier. The limits of construction, a plan view of the rain garden itself with dimensions, cross sections with a benchmark elevation nearby, and then a planting plan. If you're, bidding this kind of a project out, you might also include, or you should include, description of the contractor's responsibilities, and then your plant materials listing, the site preparation requirements, plant care, warranty, that type of things. Again, it helps keep that level playing field when people are bidding on a project. For operation and maintenance, there's quite a few elements to that in the standard about what you should and shouldn't do, but really we summarized it in a simple table, which I copied right into this slide here. And it all revolves around inspecting the rain garden 3 times per year during the growing season. And then from that, you can determine what other maintenance requirements are needed, such as erosion repair, removing the trash, removing dead plant material, and so on. Monitoring the water level after heavy rains is recommended, especially in the first year, because the soils are still kind of regaining their structures in the first couple of years. So not too difficult. If you're doing this as part of a regulatory program, an operation and maintenance plan, it will probably be required to be recorded on the deed and, maintain compliance with the regulation in the long term. So to summarize things, getting close to wrapping up here. How am I doing on time, Penny? Getting close to the end. Again, applicability, avoid the salt and target the small watersheds. Stay within those maximums for the standard. Sizing is based on those 3 factors that are built into table 2. Infiltration rate, you either gotta do a soil texture or get an infiltration test. And then the vegetation allows all types, but we definitely encourage the natives, and weeding is very important. When you get to sites that have very fine or slow infiltration rates, consider using a bioretention facility instead, where you have an engineered soil layer, or if you have larger watersheds for bioretention, you can go up to a 2-acre and you can go to a 12 to 18-inch depth. So it's just different criteria when you have a very engineered practice versus using the soils on site. So with that, I'll try to wrap up. This is a shout out. Thank you to the rain garden team. I just listed them here. It was a really engaged group of very experienced people, either on the installation side, on the planning side, on the regulatory side, or a little bit of all. We had a very good group of people to work with. And then Jennifer Thiem from the SOC, who was later replaced with Kate Brunner towards the end of the project, did an outstanding job getting this through the process and out for public review and all that. So with that, I would open it up for questions. And again, here's the website where the standard is located.
Okay, we're going to start with the questions, and I'm just going to mention again, if you want a PDH or a CEU to email me, this is Penny, and my email address is penny@wisconsinlandwater.org. And so I'm just going to kind of go down through these questions one by one. Chris Egger asked, was user guide updated, or is it the 2003 version?
No, the user guide was also updated and is posted on that website. So it's consistent with the tech standard now.
Okay. It says, this is more of a comment, there are a number of native species that can tolerate rolled salt once they are established. Clayton Fraser mentioned that. Charles said, are small trees, bushes allowed in rain gardens?
Small
Yes.
trees. Yeah.
As long as they don't shade out the rest of the rain garden, that's the thing. I would
Yeah.
kind of avoid trees.
People do put trees in. I have 5 rain gardens on my property, and one is a tree rain garden. You know, I was obviously experimenting, and obviously it's hard to grow things underneath it. So I keep it mulched. It's a river birch. It grew into an amazing tree, and the rain garden's working very well. It wouldn't be my first choice, but I just wanted to show that it worked. Some people just plant shrubs, but again, it's probably not as productive as having the prairie plants. Most of my rain gardens are prairie plants, and the ones we've done research on are prairie plants. And it's amazing how they improve the soil structure, so your rain garden keeps getting better with time.
Okay. Clayton mentioned that native vegetated mat, or NVM, was indicated in a photo. This product can work well in species selected, if species selected are wetland species and engineered soil is installed under the NVM. Any comments on that or clarification?
Well, you wouldn't necessarily need engineered soil underneath it, but I agree with, yeah, getting to a wetter mix in the, I don't know. Do you have some comment, Roger?
I don't know. If I understand the comment, and this is something I've struggled with some of our landscape people, is they think of a rain garden and they think it's wet. And so they'll plant cardinal flowers and sedges and so forth, which sometimes aren't very successful because the rain garden just doesn't stay wet long enough. If they're in the shade, of course, it works okay. But I just don't think of a rain garden as a wetland in any shape or form. I don't know if that helps, but we're just excavating the soil, some soil that's there, and we're planting plants that hopefully are suitable for the soils that Perry was talking about. You can't just obviously plant any, prairie plant in clay soils and it wants to be in sandy soils. So that's a really important part of the whole decision process. But yeah, I never think of it as a wetland.
And the manual does get into like recommending specific species for different soils, doesn't it?
Yes, it does. And it's
okay.
We took advantage of, obviously, there's a lot of very good people around our state who obviously have good knowledge of how you match the plants to the soil. So there's a lot of reference material out there.
Okay. Charles asked, what is the difference between rain garden and biofilter?
Well, biofilters are more of a general term that we've used for modeling. So the way the models, now this is how I'm going to define it for you. The way the model set up is for a biofilter, but the way it's structured, you could use it based on how you enter the data in the model. You can use it for a rain garden or a bioretention system. So to me, Perry's done a good job of describing what a rain garden is, and a bioretention system, as you said, is just a system that's been more engineered, but they're both kind of biofilters. That's how we look at it.
Yeah, I think that's a good description.
Okay. Next question. Why is there a maximum infiltration rate?
The safety factor, I think, isn't that it, Roger?
Is the person asking why would you have a maximum? I didn't quite hear what you said, Penny.
Yeah.
Okay. Why is there a maximum infiltration rate?
Okay. Perry's already mentioned it. I mean, there's in the business of trying to work with basically nature and trying to put a lot of water in a place and have it infiltrate and do some work for us. We've always found a need to be conservative. So 2 inches an hour was selected as a conservative number. I mean, I don't argue that in some places, and I've done double rings myself in different places, so you can get 5, 6, 7 inches an hour. But again, given what we're dealing with here, something could become clogged. Something could happen during the construction process. Remember, the 2 inches per hour is for the design. And so if somehow you think it's 5 inches an hour and you disturb the soils enough, you might end up with 1 inch an hour. So in all the standards we've written for infiltration devices, and there are a number of that we haven't talked about, we are very conservative because of what can happen during the process of construction and even after something's built. We don't want people to have failures. So we're forcing this issue in a way of saying, go with us on this. It's a conservative number, but hopefully it gives you the greatest chance of success now and in the future.
Okay, I have another comment. Native plants do not need high quality soil, topsoil, to grow, but will grow faster in good soil. If soil is not of high quality, additional maintenance will be required, as invasive and or aggressive vegetation will be more prolific in poor soils. Do you want me to read that again, or?
I'm not sure what the question is, Perry. So.
It's not a question. It's, I think, just Clayton just putting his information out there. I don't know if you agree with it.
Yeah.
Native plants do not need to be high quality. Do not
I
need
mentioned
high
that
quality soil.
when you're digging the rain garden and you're getting into, more porous soils on the bottom. And I was saying that, if you're going to plant turf, you might want to save a lot of topsoil and reapply it at a significant depth. But if you're planting natives, yeah, they don't need that much, just a little bit of growing medium. And do you agree, Roger?
I agree. And people I've talked to who are, prairie experts and so forth through the years have told me actually our prairie plants can grow in sand. In fact, the prairie plants are what grew our prairies. I mean, they created this amazing soil that our farmers use today. They created that through the dying of their root systems and or so forth. I tend to want a little bit of organic matter in there to hold the moisture and stuff, but they can grow in pretty sandy soils. We have one rain garden that we've done research on where we worked with Agricole, and they selected plants that would grow in sandy soils. And after 2 years, we have about 90% survival.
Okay, another question.
If I was going to do this myself, not in a research project, I would probably add some. If it was pure sand, really sandy soil, I would prefer to have it, some organic matter in there.
At least in the top inch or two.
Yeah, as Perry was saying before, you can put a couple of inches of compost and something and just kind of rototill it in. Yeah. Mm-hmm. Which is really easy to do if the soil is really sandy. So, yeah. Okay. You can try it. Obviously, this is all a learning process. If you want to try just finding the right plants for a very, very sandy soil, then you want to try it. I would just be very, very careful, as Perry was saying, to water these things initially, especially if it doesn't rain. They need water, so the more sandy the soil, the less it's going to hold the moisture, obviously.
What is a good source for prairie sod / mat?
Oh, I'm not sure, Perry, where they get that from.
I don't know if we're allowed to advertise different companies either, but they're available.
They're available. If you go to the big companies, I have the same problem Perry does. I know names, but I can't name them. But the bigger companies would certainly have this. So.
Okay. There was something in the chat line that I'm just going to read. I'm not endorsing them at all. Agricole sells NVM, and I can't remember, I think it was Clayton Fraser. He's CFRAZER at eco-resource.net for more info on cost and site applications. So,
Sounds like an advertisement.
Yes, yep. If a rain garden clogs, does the standard specify how to fix it? And that's our last question.
Yeah, I touched on it a little bit about if it's due to compaction, you know, you can rototill some kind of organic matter into their compost. That's probably your best bet. What do you think, Roger?
Yeah, so the thought here is that the rain garden has failed and you want to sort of restore it.
That's
somehow.
The thing, it depends why it failed, I don't know.
Yeah, see, I mean, it's usually if a rain garden fails, it fails immediately. I've seen this over and over again. And it's all for all the reasons that Perry's been talking about, you know, compaction and so forth.
Soil.
So to restore the soils can be a challenge. I had one rain garden that failed immediately. And so the homeowner called and we went to the site, and it hadn't rained for, at least 10 days. And the rain garden was about 1.5 feet deep, so it's pretty deep. And the water was just standing in there. So we got a hose and siphoned it out. And the bottom had a glaze to it, which those of you familiar with that means a bobcat drag just laid back and forth. So she was distraught. So I knew it'd be a lot of money to dig that soil up and replace it. So since it was so deep, we had her bring in some sandy loam, some nice soil, divert her downspout away, plant her prairie plants, and 2 years later it was working fine. It always comes down to cost, because the homeowner usually has fairly big restrictions on having a $5,000 bill to complete your race-based soils and stuff. But again, Perry is saying over and over again, you have to prevent it. And we called that company and said, why'd you do that? And well, this is why there's a good webinar.
Site assessment, do the soil test.
Okay, that's all the questions I have. So thanks, Perry and Roger, for the great presentation. Any final thoughts, Perry or Roger, that you'd like to share with the group that are left?
Well, I thought Perry gave a great presentation. I think the technical standard is really a good tool for people to be successful. And so is the manual. That's always been my desire, working on all these committees and stuff and doing all the research, that when people want to do something to help our environment, they're successful. So very frustrating to spend the money and have it fail. So
yes, I agree.
Well,
and I think they're tired of listening to me talk. So thanks, Penny.
Great job, guys. Thank you so much. Have a great afternoon, and we'll be in touch.
Okay.
Thank you.
Thanks, Roger.
Bye-bye.
Goodbye.